Hello, everyone. Billo Nerone here, Master of Wine. Wanted to talk a little bit about Veraison, kind of what's happening in the vineyard today. Very exciting things. We are almost completed with Veraison. Another couple of days, I think we'll be fully there. And so we're 4 to 6 weeks away from harvesting grapes. The first things that typically come in, Chardonnay, Riesling, that type of stuff, probably be in early September. And then the Syrah, kind of around the September 15th, September 20th time zone. And then Merlot, Cab Franc, things like that will start coming in. Cabernet Sauvignon in October, typically. Anyway, let's talk about that a little bit. So Veraison, I think I showed this picture last time. You can see this. It's mostly done throughout the block at our property. Sorry, the wine I'm drinking. Although I'm not, I perhaps shouldn't explain it right now. It is my personal project. Just kind of checking in on it. I'll give you all the full details on this. This will probably be released in the fall, and I'll do a video on that later. But I couldn't be more pleased with the wines that will be coming out. So anyway, back to Veraison. So we are pretty much at the tail end of Veraison. This is the point where the grapes, red grapes, change color. All the grapes start softening, white and red. Right now, prior to Veraison, there were these hard little nuggets, so to speak, on the vine. Now they're starting to soften. The color change happens in the red varieties as that visual attractant to the birds and animals. And then the major thing that's happening now is this shift towards ripening the fruit. So the seeds are at a mature state. So now the vine is shifting gears to ripening the berries. That means sweetening up the berries quite a bit. So if you recall from a previous slides that we did presentation, I had presented this slide. So here, just to kind of recap everything, initially when the berries are really small, seeds not viable, the plant makes it a very, very unattractive for any type of animals to come eat the berries. So it pumps it full of acid, tannins, all these bitter compounds. And this is the stage 1 growth. After flowering and fruits that happens, this goes through mitotic division very, very rapidly, increases the berry size, and then kind of hangs out. But at this stage, the seeds are not viable. So the plant does everything it can to make it extremely unattractive to eat the berries. And then it goes into this phase 2, so initial burst of growth. The phase 2, this lag phase, is focusing primarily on ripe or maturing the embryo, getting the seed ready for to be able to plant later, etc. Once that is done, now Veraison hits as that seed matures, and now the plant is focusing on, well, how do I make it attractive for the birds and animals to come eat it and hopefully deposit the seeds elsewhere and generate another plant. So we obviously don't want the birds coming and deer eating it and all that stuff, so we do put appropriate netting on the vines. We typically do it at this stage once the color shifts. So now the seeds are technically speaking viable, can be planted in the ground under right growing conditions. It will generate a new plant. So the plant switches to a sugar accumulation mode. So prior to Veraison, the sugar, the photosynthase that were developed, were used as the means for generating energy for the plant's metabolic activity. Now, as Veraison hits, the seeds mature, it wants to sweeten up the grape. So it no longer uses the sugar to drive its metabolic activity to generate the ATP, energy currency of the cells that we talked about in that respiration cycle, right? The respiration cycle leads off with glycolysis and then goes into the Krebs cycle and then oxidative phosphorylation. So if you recall, let me go down one slide. In the Krebs cycle, as we discussed last time, malic acid, malate, is a direct component in the Krebs cycle. So at this stage, since it wants to accumulate sugars, it starts pumping the photosynthates, primarily sucrose, into the berry. Once it reaches the berry, the acid medium and water medium in the berry kind of hydrolyzes the sugars, and it converts the sucrose into glucose and fructose inside the berry. So that's what there's no sucrose present inside the berry. It's glucose and fructose. So now if it's not using sucrose or glucose for the energy needs, it needs to use something. So it switches to malic acid. Now this is part of the Krebs cycle too. So this will go through this cycle, go through the oxidative phosphorylation step, or sometimes you may know it as the electron transport chain. That's fine. The main goal of that is to generate ATP, the currency molecules. So that shift is being made now as Veraison is completing. The sugar is going to accumulate. We're going to start using malate, malic acid, as the source for metabolic activity. So the acid, the total acidity in the grapes is going to start declining because now it's going to start consuming some of that malic acid. So we will see as Veraison goes, as we progress this next 6, 7, 8 weeks towards harvest, the acidity, total acidity in the grapes are going to start dropping. And that's primarily because the malic acid is being consumed now. And this is a temperature dependent reaction. So in regions like in Washington, where we have a strong diurnal shift, that is, it's very hot during the day, it may cool off, dip into the 60s at night, that respiration cycle breaks and we are able to preserve more acid naturally even at harvest. So in very hot climates, equatorial climates, that doesn't really happen, right? So the grapes will come in very, very low in acid, and then the only means to balance the wine is to add a whole bunch of acid at the crusher or during the fermentation stages in order to have a balanced wine. Here in Washington, we're kind of blessed with those cooling nights, that strong diurnal shift, that we're able to preserve the acidity to a good level. So as this happens, so now post-Veraison, the color is changing, and now we're going to see another huge increase in berry size. So what's going on here? This is no longer due to mitotic division. This is purely going to be a cellular expansion, and it's expanding because the solutes, the photosynthates, are being pumped into the berry now via the phloem. It's finding its way into the cells and enlarging the cells. So no mitotic division at this point. It is just this solute accumulation that's happening in this stage leading up to harvest. One of the other things, so this glucose fructose driver here, and this switch to malic acid in the respiration cycle. Another key thing that's happening is this anthocyanin in red grapes, Syrah, Cabernet, etc. The color is changing. Now that color is development of these anthocyanin compounds. There are 5 major anthocyanins in Vitis vinifera. And they are what give it that beautiful color, that deep dark color for a Cabernet or a Syrah or things like that. That's all anthocyanins. And then you'll see a lot of flavor compounds. Now here, these are all huge chemical kind of soup matrices here, right, that are being built. Is very, very, I think I've got a slide here. So here are the anthocyanins. It's quite complicated structure. It's a 3-ring structure known as the ABC ring. So here on the B ring are these R group substitutions. So depending on what is attached here at this R1 location, R2 location, will determine the specific anthocyanin that it is. So in the case of cyanidin, so these 5 anthocyanins are present in the Vitis vinifera. So this is a glucose molecule that is attached at the 3 carbon position off the C ring. If this glucose molecule is attached, it is known as an anthocyanin. If this glucose entity, moiety, is not there, it is known as an anthocyanidin. It's okay, don't get too hung up on this. The key thing is these substitutions at the R1 and R2 position, if it's a hydroxyl group or a hydrogen atom attached to these, it'll be a cyanidin. If it is this OCH3 group attached here in these positions, it'll be a malvidin, and that is the defining structure of these anthocyanins. So the dominant anthocyanin that's being developed is malvidin 3 glucoside. So this glucoside helps to kind of stabilize the color. If this glucose isn't there, this portion can be attacked by various things. For example, sulfur dioxide, especially in the bisulfite form, can attach here at this position, and it'll render that anthocyanin kind of colorless for a while. It's this bleaching effect, kind of a well-known bleaching effect of SO2 and anthocyanins. That is a reversible reaction, and the color will come back as the free SO2 drops. But so depending, anthocyanins are kind of this curious thing at low pHs, kind of pH 3, 3, something like that. It'll be a dominant red color tone. As that pH increases to 3.7, 3.8, 3.9, 4.0, it will shift to a more bluer purple tone. And even if you take the pH all the way up to like 7, which doesn't, no wine would be at that level, that's kind of a neutral pH of water, but at pH 7, the anthocyanins will actually become colorless at some point. So depending on the pH of the wine, it exists in this kind of more red form or this more purple form. But the compounds get very, very complicated very, very quickly. So not to scare you off with the organic chemistry or anything, one thing I do want to point out, so this kind of relates to fraud, various things in, people like darker wines. So the Vitis, Vitis vinifera is what we use for winemaking, Cabernet, Syrah, all Vitis vinifera species. Vitis vinifera only develops monoglucosides. Vitis labrusca, for example, Concord grapes, etc., numerous other Vitis species that have very dark color, sometimes have been used to adulterate wine to get a darker wine. And those exist mostly in a diglucoside form. So 2 sugars are attached, typically off this 3 position and off this 5 position, and they're known as diglucosides, malvidin 3,5 diglucoside. So it is very easy for us to tell if a wine has been doctored with non-vinifera wine, because we just look for the presence of diglucoside anthocyanins, and we know that someone's been goofing around, right? So very easy. So if it's pure Vitis vinifera, we'll just see these the glucoside, the 3 glucosides, the monoglucosides of anthocyanins. Okay, so let's go back to so the other compounds that I was mentioning. So it's at this late stage, are all these chemical compounds being developed? After, largely speaking, once the Brix accumulation goes to 20, I'm just going to go back to this other slide real quick. So this anthocyanins are being developed, and anthocyanins are largely dependent on sunlight hitting the grape berries directly. If it's very low sunlight, like if it's got if the foliage is so much and you didn't thin out the canopy, no sunlight hitting the clusters, you have very, very poor color formation. So it's important to open up that canopy, let sunlight hit the berries to maximize the anthocyanin development. And then also, one thing I would point out is this flavor compounds are late in the cycle, right? After the Brix have accumulated, there's no hard and fast triggers. These are all kind of loosely coupled, but by and large, late in the ripening cycle, the flavor compounds develop. And this is more of this organic chemistry soup. So not the, you'll see hydroxycinnamic acids, benzoic acids, resveratrol. You may have heard of that compound. It's good for, that French paradox thing. They were saying, wine's good for your heart and stuff. That was mostly the resveratrol they're measuring. Other flavanols, flavan-3-ols, catechins, epicatechins, these tannin structures, all of these things are being developed, right? So I just want you to take away is that this host of this organic chemistry compound soup that's being developed here, all of this will go on later during the primary fermentation. The yeast are going to massage these things into other compounds. During malolactic fermentation, the bacteria is going to massage these things into other compounds. So these are all precursors that are going to lead to a host of different other compounds in the wine that are going to contribute attribute that beautiful palate complexity, that aromatic complexity, but it all starts kind of here at this stage. So if during the ripening process, as this is going, the grapes are getting sweeter and sweeter and sweeter. They're vastly sweeter than table grapes that you'd buy at your local Safeway or whatever. Those are typically 12 to 14, maybe 15 bricks in sugar. We're picking stuff that's at 24 to 27 bricks in sugar, almost twice as sweet, and they're vastly more flavorful than any table grapes you'll buy at the supermarket. So all of those compounds happen late in the cycle. So if you are, I know a lot of winemakers, once they see a bricks of 24, 25, they rush to pick. And I think it's a bit of a mistake, right? You need to wait. The flavor compounds will develop when they develop. Sometimes it's earlier in the cycle, slightly, sometimes it's later in the cycle. But whatever that trigger is, you want to wait for that flavor. You can't add flavor back to the wine, right? Those compounds have to be there. And similarly, these phenolic compounds, the tannins and the hydroxycinnamons that were pushed in early in the cycle to stop the animals from eating it because they're very bitter, harsh tasting, these kind of go through a ripening phase as well as it ages. And there is a shift in the character of the phenolics of the tannins where they become a bit softer and not as bitter, a little less aggressive on the palate. So it is really up to the winemaker when you want to pick based on the sugar accumulation, the amount of acidity in the berries, the flavor compounds that are developing, and the resolution of these tannin hydroxycinnamons, these phenolic compounds, to a more gentler state. And it really is going to depend on the style of wine that you want to make ultimately. But these things are happening late in the cycle, so you do kind of have to wait for that to happen. So exciting times in the vineyard leading up to harvest here. So now we are kind of in full mode here. This is the time of year where I increase my vineyard visits quite a bit. So I'll be in the vineyards once or twice a week at least as leading up to harvest. And then once we get very close to harvesting, once it gets quite close, we think within 3 to 5 days we're going to pick that type of closeness. I'm out there every day just tasting. And once everything is appropriate, in balance for the palate, for the style of wine that we want to make, then we just pull the trigger and harvest the grapes. So this is kind of what's happening at this stage. I will, as we go along, get some photos in the vineyards and maybe time in the vineyards when we start to tasting the grapes and all that stuff, and kind of discuss some of the phenolic developments that are happening, flavor developments that are happening. And then also upcoming, we'll start talking a little about the chemistry of the winemaking process as well. So fun stuff happening. We did have just an update on the smoke situation. We did have a little bit of smoke happening in July. It is subsiding, so hopefully we won't have any smoke type of issues, smoke taint issues here in Washington, but we are watching it and monitoring this closely. All right, so thank you for watching this. I'll be back in a few more days talking a little bit more about the ripening process and maybe touch into some chemistry of winemaking. All right, thank you. Talk to you soon. Bye-bye.